One of the themes that we've seen time and time again is the effect on surface area when we take a shape and dilate it, expand it by a particular scale factor. Well, let's see what happens when we take a right cone, okay, and let's examine the surface area when, in fact, we take a look at the cone as is, or after we actually scale it by doubling each of the lengths and the slant height, doubling it, so multiplying by 2. All right, so first let's just find the surface area as is. So the surface area we know how to do that. So the surface area is what? First we find the lateral area, which is going to be pi r, in this case 2. Slant height is given to be 7, and so I see this is going to be 14 pi. But I've got to add to that the area of the base, which is going to be pi r squared, which is going to be 4 pi. And so I see that the surface area equals 18 pi, and my units are feet squared. Okay, now I want to compare that to what we're going to get when we actually double these lengths. So now let's double the lengths. Let's change 2 to 4. Let's change 7 to 14. And compute the surface area now and see how that affects this answer. Okay, so when we compute the surface area now, what do we see? Well, I've got the lateral is going to be pi times r times the slant height, which is 14. And so that part just alone gives me what? Well, that's going to give me, let's see, 56 pi. But then I've got to add on the area of the base, which is pi r squared, but now the r is 4, so that's going to be 16 pi. And so I see now the new surface area is going to actually equal this sum, which is 5, 6, and so it's 72 pi feet squared. And what do we notice about 72 pi? Well, I see that, in fact, 72 pi is nothing more than 4 times 18 pi. And you can see the 18 pi here. And so the surface area actually was multiplied, not by 2, which is what we doubled here, but in fact multiplied by 4. So when you take the length dimensions and you multiply them all by 2, the impact on the surface area is we see that the surface area gets multiplied by a 4. Surprising? No, I hope it's not too surprising at this point, because when you think of area, remember it's units squared, and so if we change each length by a factor of 2, that should be 2 times 2, which would give us a factor of 4 for the surface area. And that's being confirmed here in this particular example. So again, we see reflections of the fact of the impact when we take lengths and actually dilate them, the impact on, in fact, the surface area. Cool.